This is section 3.5, and we may get to 3.6 in here, we'll see. So this section of your textbook talks about loop structures. Loop structures are used to implement repetitive tasks. So I don't want to print a statement 10 times, I would put it in a loop structure. Since you have now been introduced to loop structures, never again do I want to see some repeated code in your programs. So there are three types of loop structures that we can use in C and C++ for that matter. There are a while loop, a do-while loop, and a for loop, and they are a little different. I'm also going to tell you about two modifiers to loop structures, break and continue. We already saw break in our switch statement, but we also have break and continues in these loop structures, and I see I typoed statements right there. I guess I should fix it. Continue statements. Okay, so here's just basically the structure of the three different loop structures that we're going to look at. One is called the while loop. So you're going to say while, and then there will be some condition that you're going to test. So while this condition is true, you'll execute the statements of the while loop. And then somewhere during this while loop, you've got to change the condition, change the iterator that's going on. That will become clear in a moment. So the condition is given at the beginning when you're first entering the while loop. So this is a pre-test condition. A do-while loop enters the loop right away, executes the statement, so no matter what you get one execution of the loop, and then the test for is the loop done is at the end of the first iteration of the do loop. So every time you go through a loop, it is called an iteration. And the last loop structure that we have is called a for loop. It's the loop I use the most. It's my favorite loop. Your book says that the structure of a for loop contains the for keyword, and then in parentheses it writes 3 expressions, and it doesn't tell you more than that. But formally, the expressions are an initialization expression, a condition to be tested expression, and an increment or decrement expression. A for loop is actually a convenient way of writing a while loop. So I think these are going to be best shown by example. So let's do first a while loop. This is the while loop example. So the conditions that you use in the while loop. I'm back. I got distracted for a moment. So the conditions, the variables that you use in your condition that you're going to test have to be declared initially. So identifiers that you are using have to be declared. So I'm using an integer called degrees, and I'm initializing it to the value of 0. And then I'm using another identifier called radians. So this program is going to be converting degrees to radians over and over again and creating a table. So I don't want to do the conversion 100 times or whatever it is. I want to put it in a loop. So I say while I initialize, before I enter the loop, I have to initialize degrees. Degrees is at 0. And then I say while degrees is less than 360, less than or equal to 360 degrees, I'm going to do the conversion and print the answer. And then I'm going to increment degrees by 10 degrees. So I should be putting out at 0 degrees, 10 degrees, 20, 30, all the way up to this test, all the way up to 360 degrees. This loop does not work if you do not initialize it before you enter the loop. So I have to initialize my iterator, which is degrees. I have to initialize it at some starting value. I'm going to run this just to show you what it outputs. Actually, I think I already have compiled it. Let me check. Yes, I have. So it is this example right here. And so this is what it does. It outputs 0 degrees is that many radians, 10, 20, 30, etc. So that's what it does. Just puts it out one new line at a time. I'm going to modify it slightly. I'm going to make it smaller just to make it an easier example to follow. So the question is, I start at 0, degrees is 0, I go through the loop one time, I do a conversion, then I increment to 10 degrees, I go back, I do the loop over again, it's still less than 60, so I increment by 10 degrees and go back and do the loop again until this test becomes false. So when degrees becomes 70, this test condition is now false and the loop structure will no longer be executed, but you will go to the end of the program. So let's save it and run it as a smaller amount, and then we can play some games with it. Oh, I didn't recompile it. Didn't get that right. 3.2, right click, there it is. Okay, so now I can see it better. It starts in at 0, it goes through the loop until degrees is less than or equal to 60. When it's equal to 60, it can go through the loop one more time, and then it will exit the loop after that. So let's look what happens if I say degrees is less than 60. Execute the loop one more time. So I go through, I increment, and one pass through the loop is 50, then it gets incremented by 10 degrees to 60. When I come through and I've incremented it, I put out the value for 50, I incremented it to 60, but then it no longer, this condition becomes false, so I exit the loop and come back down here and finish the program. What happens if I mess up and I put the sign in the wrong direction? If I do this, I will crash the program and I will have an infinite loop that you will struggle to get out of. I'm going to compile this program and let it be in an infinite loop and see if I can actually get out of the infinite loop. I think it's a Control-C that gets out, so I am just going to test it and see. Save that first. And if I mess up, I will probably have to close my PowerShell and get out of it that way. So let's demo infinite loop. Oh, it got out. Let's see. Oh, I know why. If degrees are greater than 60, so I never executed the loop at all, so that didn't do it. I want to create an infinite loop. I will start my degrees at 70. So yes, degrees are greater than 60. It's going to keep incrementing and incrementing and incrementing. So one more time, I will create this infinite loop. Oh, infinite loop. So Control-C, I believe, is supposed to kill it, and yes, it is. So remember that if everybody at some point in their life usually inadvertently creates an infinite loop, Control C to get out of your infinite loop. I don't want to keep that. Control C to get out of your infinite loop. All right, this is the while loop. You must set up the initial conditions before entering the loop. There's a condition statement here. While you are in the loop, you must increment or decrement your loop. I could have gone the other direction. I could have started at 60 and say while the degrees are less than 60, I'm going to run the loop, but I'm going to decrement instead. So this should run the loop backwards. And I made a mistake in my loop. So looking back at my code, what did I do? While degrees is less than 60, it wasn't less than 60, it was equal to 60, so I never executed the loop. Let's say while degrees is less than or equal to 60, and I think my loop shall now decrement instead. Oh, another infinite loop. Did you see what I did wrong yet? So I decremented it right while it's less than 60, and I keep decrementing it, and so it's going to be forever more decrementing by 10, and I don't want that. So what would be an actual good thing to do? I want to go 60, 50 down to 0. So while degrees is greater than or equal to 0, then I should be okay. I did this all intentionally. You believe me, right? And there it worked correctly. So watch out for that. Watch out for infinite loops. Watch out for your starting values and your ending values and your direction of your inequalities there. So let's look at the next structure. That is the while loop. Let's look at now this is the do while loop. So do while loop, again I initialized degrees. This program is going to do the same thing. It will, no matter what, execute one time through this loop. It has no choice. There is no condition to give it otherwise. So it will enter the loop. It will do the calculation and output to the screen at least one time, and then it increments my degrees iterator. And then it does a test while degrees is less than or equal to 360. If that is a true statement, it will go back and run the loop again and again and again. So this loop actually works exactly the same way. I'm going to change that to be 60 and show you the program. Make sure I have it there. I do. It is 3-3. And so it works exactly the same way. So that's the do while loop. The main difference between this loop and the other loop is that no matter what, you will execute the loop one time, which you may or may not want, depending on your program. So the last loop structure is a for loop. Here is a for loop example. This is my favorite. I do not have to remember before I enter the loop to have an initial value. So you can see that degrees is not initialized to 0 in this program. But the for loop instead has an initialization statement right here. Then it has the condition statement right here, the test that you're testing. And then it has the iterator, the increment or decrement statement right here. So it's kind of an all-in-one thing. Whereas the while loop, you had to initialize outside the loop, and you had to increment or decrement within the loop, but the for statement is an all-in-one function. Note the syntax for a for statement. It's for with parentheses, your three required expressions in parentheses. There is no punctuation at the end of the line, and the body of the for loop is enclosed within curly brackets. And this program will run exactly like the other two examples. To me, this for loop is the most efficient way because the three expressions, the initialization, the condition test, and the increment or decrement function are all on one line. If I use a while loop, I'm prone to forget some part of the loop, especially like the iteration with inside the loop. So those are the three structures. Let's go on and talk about the break and continue statements. So now let's look at the break and continue statements. These are used to get out of a loop iteration early, and they are also useful when error conditions are encountered. So again, I think this is best shown by example. So I have already put in the code that's on page 108 into a full program because the code on page 108 leaves something out. For example, they just start off by saying the sum is 0, and the author doesn't declare it as a proper declaration first. So the code on the top of page 108 is a little bit sketchy. So anyway, I programmed it into a full program. So this particular program uses a for loop. It gets input from the user and it sums the numbers all up, but up to 20 numbers. So I'm going to do this loop 20 times. I will sum 20 numbers up. I get the user input right here, but I do a test right here. If the number that the user entered is greater than 10, so the user must really only be able to enter numbers less than 10. But if he enters numbers greater than 10, I'm going to do a break in the program, and let me show you what that means, what will happen. It'll break out here. So I am going to go ahead and let me check that I saved this program the way it is. No, I didn't. Let's save it, and we will go back and execute the program. First, let me show you where the user doesn't enter a value over 10, how it functions. So I will recompile and turn integers to add. So remember, the program's asking me to add 20 integers, and they should be less than 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so there. It added up my 20 numbers and the value was 20, no problem. So let's run it again. So I'm going to 1, 2, 3, 4, and I'm going to put a big number in there, 22, which is over 10. And so the program execution jumps out of the loop right now, and it only totaled the numbers that were less than 10, and it didn't include the 22. So that was the use of the break statement. It ended adding up the numbers and jumped out of the loop. Look back at that program. So it was adding numbers up until the user entered something greater than 10, and then it broke out of the loop and jumped down here and reported what the sum was, but it did not include the value greater than 10. So now let's change this program and put a continue statement in instead and see how it behaves. So it should function first normally like the other program did. So I'll go ahead and show you that it does. Yes, no problem. So now let's run it again and run it abnormally. 1, 2, 3, 4, 22. So what it did this time is it continued, the program continued, but it skipped summing that number in. So if we look at the program, if x was greater than 10, continue, but it misses summing the number in. It continues, it goes back up here and continues the loop without, it jumps out at this point, not completing the rest of the execution, and goes back to the start of the for loop for the next iteration. So section 3.6 is a application. It is problem solving applied. It is a large problem about wave interactions. I think I'm going to postpone putting that in this video because I will go over wave interactions, which is summing up two waves and coming up with a new wave height. But I'm actually going to postpone this problem until we can show you a little bit of plotting functions, because this problem would be more useful if you could plot your results and see how the waves add up to each other. So I will postpone section 5.6 for another video. You now have enough from chapter 3 to be able to do your homework. So I'm going to post this video and post some homework out of chapter 3 for you, which will be due this coming Friday. All for now.